Okay, so first step in any prediction problem is that we have to do what? Right, identify the type of reaction, because that's the only way we're going to figure out what's going on and what's going to be on the product side. All right, so in this one here, I've got an element reacting with a compound. Only reaction type that starts that way is single replacement. All right, in a single replacement reaction, I have to identify the type of element that is reacting. Potassium is a metal, so it is going to change places with what in HOH? With the H, right. Okay, the first H because that is acting as the metal, which means I'm going to have KOH on this side, and I'm going to have H2 on this side because hydrogen is special. It's one of our molecular elements. All right, now we go back to balance. I need to put a 2 here to balance my hydrogens, a 2 here to balance my OHs, and a 2 here to balance my potassiums. Okay, everybody good with that? Nathan. The book away. Okay. Next one. I have 2 ionic compounds reacting. Double replacement. What do we do in a double replacement reaction? Swap the metals. All right. So Cu is going to end up with OH. Okay, and sodium is going to end up with sulfur. All right. They're both ionic compounds, so I have to do what with them? Drop and swap, swap and drop, whichever order you like to do it in. Okay, so for this one here, sulfur's -2, sodium's +1. Okay, when we drop and swap, we get Na2S. All right, this one, copper, is a multivalent metal. Can I figure out from the reactant side which charge it had? Yes. Okay, if I look at this, there were 2 coppers needed to balance the 2 negative charges that were on sulfur. So what was the charge on each of the copper? 1. All right, so that means that this compound is fine the way it is written, because this is +1 and this is -1. Everybody got me there? All right, so now we go back and we balance. There's 2 sodiums over here, and I need 2 over here. That gives me 2 OHs, so I need to put a 2 there, which makes my copper work. There's 1 sulfur on each side, and we're good. Cool. Yeah, but there's 1 sulfur. There's 1 sulfur. Each sulfur is -2. If copper is negative or is +1, 1 times 2 is 2. Yeah? All right, next one. Element reacts with element. What kind of reaction is that? Synthesis. So they have to go together. Now, iron is a multivalent metal. And since it was an element on the reactant side, there's no way for me to know what its charge was, so I go with the most common. First one is +3. Oxygen, -2. Drop and swap, 2 and 3. Okay, now we have to balance. We can put a 2 in front of iron, but that's not really going to help us, at least initially, because there's an odd number of oxygens over here. Okay, so what do I have to do with the number of oxygens? Double it. That gives me how many oxygens now? 6. Okay, so I need a 3 there, and how many iron are there? 4. Okay. All right, number 4 starts out with just a compound, which means it's what kind of reaction? Decomposition. What do we always have to watch for in decomposition reactions? Special elements. Both of these are special. Okay, nitrogen always comes as a pair. Phosphorus always comes as a set of 4. All right, so now we have to balance the reaction. Start with the thing present in the highest number. So that means I need a 4 here. And how many nitrogens does that give me? 12. So a 6 there will do it. Questions on those? Okay, then we'll look at number 5, and I'll give you a few more minutes on the rest. What kind of reaction is number 5? Double replacements. 2 ionic compounds, so we swap the metals. Okay, that means that calcium's new partner is going to be what? Nitrogen. Okay, and manganese's new partner is going to be fluorine. Now, this is really important. I know that seems like kind of simple, but I saw a lot of people yesterday when they were predicting the products for the reactions lab putting metals together. and nonmetals together in compounds on the product side, right? Especially when hydrogen was involved. All right, we have to be really, really careful when we're dealing with replacement reactions. Remember, we can only make ionic compounds in replacement reactions. Okay, that means metal, nonmetal, metal, nonmetal. We can't put two metals together for a couple of reasons. That's not an ionic compound, and secondly, metals don't chemically bond to each other. All right, everybody with me there? Okay. So now we got to swap and drop both of these. This is -3, this is +2, so we'll have Ca3 and 2 for that compound. Manganese in this compound had what charge? 4. How do we know that? Well, okay, every nitrogen is -3, so that's 12 negatives. So this had to be +4 to make up 12 positives. Everybody follow? Okay. So +4, -1, so we're going to have MnF4. So we got lots of big numbers to deal with here. Okay, I think we'll start with maybe making nitrogen work. Okay, let's. We got 4 on this side. How many over here? 2. Okay, so let's put what here? A 2. How many calcium does that give me? 6. So I got to go back over here and put a 6 there. That gives me how many fluorine? 12. So what times 4 will give me 12? All right, that gives me 3 manganese. I come back here and find that, hey, it's all set up already. Okay, so now everything is balanced. All right, I'll give you a couple more minutes to do the last 5. Okay, and then we'll go over those together here. All right, let's go through the last few here. So number 6, I've got lithium bromide reacting with phosphorus. What kind of reaction is that going to be? Single replacement. Again, I've got an ionic compound reacting with an element. This time the element is a nonmetal. So who is it going to replace? It's going to replace bromine, because bromine is the nonmetal in this ionic compound. That means lithium's new partner is phosphorus, and bromine will end up by itself. Now our rules always say, check for ionic compounds, drop and swap. So we'll do that. -3, lithium is +1, so we got Li3P for our ionic compound, and then check for special molecular elements. Bromine is one of them, comes as a pair. Okay. Now, I'm not trying to belittle your intelligence by repeating the rules over and over. I just do that because it's habit. Okay? It's always good to hear the rules again. All right, now we got to balance this thing. Phosphorus present in the largest number. We always start with what's in the largest number unless it's oxygen. Let's put a 4 here. That gives me how many lithium? 12. So I got to go here and put a 12 there. All right, that gives me 12 bromines, so I need a 6 there. And now everything is balanced. Back. It's one of the molecular ones that we highlighted in our periodic table. Okay. Okay, number 7, I've got a compound containing carbon and hydrogen reacting with oxygen gas. Only one kind of reaction starts that way. Combustion reaction. Products of a combustion reaction are always CO2 and water. All right, special balancing rules. Balance alphabetically and the rule of 2. Do we need both rules on this one? No, because carbon is an odd number on this one. All right, so carbon, there's 9 of them, so I put a 9 here. There's 20 hydrogens, so I need a 10 here. Now I can balance the oxygens. 9 times 2 is 18, plus 10 more is 28. What times 2 gives me 28? 14. All right, on number 8, I've got an element reacting with an element. What kind of reaction is that? Synthesis. All right, so cesium and sulfur have to end up together in a, whoops, not 8. Okay, in a compound. Now, cesium is usually a +1, yeah? Okay, and sulfur is always a -2, so when we drop and swap, we get CS2S. What should I balance first? Sulfur, present in the largest number. Need an 8 here and a 16 there. Okay, number 9. What kind of reaction starts out with 2 ionic compounds? Double replacement. So in a double replacement, we swap the metals. Zinc will end up with chlorine. Rubidium will end up with oxygen. Okay. Now, we've got to do our drop and swaps here. Zinc is +2, chlorine's -1, so we got ZnCl2. Rubidium's a +1, oxygen is a -2, so we'll have Rb2O. And then we have to go back and balance. There's 2 rubidiums here, so if I put a 2 there, that ought to do it because that balances the chlorine as well. Okay. Okay, and the last one, carbon-containing compound with hydrogen reacting with oxygen. Combustion reaction. Products are carbon dioxide and water. Okay, balance alphabetically in the rule of 2. Do both apply here? Yes, carbon's an even number, so start with a 2. That makes 16 carbons. Okay, 2 times 18 is 36, so I need an 18 here. All right. Have you noticed that pattern always? Right? Whatever number was on hydrogen here is what goes here. Yeah? Okay. All right. So we've got 18 times 2 there. Now I got to get my oxygens balanced. 16 times 2 is 32, plus 18 more is 50. What times 2 is 50? 25. Okay. Making sense? Okay. People starting to feel okay about this? How many people have done the prediction worksheet I gave you on Friday? Hands up. Okay. If you're not done the prediction worksheet I gave you on Friday, that's what I want you working on right now. Okay, I'm going to give you a few more minutes. We'll go through any ones that give you trouble on that. And then I've got a couple other prediction ones I want you to do. And I know it seems like we're spending a lot of time on this, and we are, because it's big marks. Okay, we have to be able to do this to do, the next thing that we're going to do, to be able to get full marks on your lab report for your reactions lab, all that kind of stuff. Okay. Plus, it essentially works on every skill we've used thus far in the unit: making compounds correctly, dropping and swapping, naming stuff. It's all part and parcel, right? Okay, guys, there's a mistake on my key. All right, so you need to check here. Number 16, copper sulfate is CuSO4, reacts with iron solid, Fe. All right, I have the answer using the 2+ charge for iron. Should that have been what I used? No, because 3+ is the most common charge. So the answer should read Fe2SO4 in brackets 3, okay, with Cu, and then you have to balance everything, so you got to put a 3 here to balance the sulfates, and a 3 here to balance the copper, and a 2 here to balance the iron. Okay, so there is a mistake on the key. You want to check number 16, make sure that you did it right and not the way I did it, which was wrong. Okay. Guys, same thing here. I have a typo on number 20 on this one. It says lead nitrate and doesn't tell you which one. It's lead 2. 2 is the most common charge there, but I should have a Roman numeral 2 on number 20.